I just want to begin by saying I love this example so much because it literally asks every single question I can possibly ask on graphing and linear relations. It talks about creating a table of values. It asks us to identify the dependent and independent variables. It talks about continuous data. It asks us to create an equation. It asks us if it's linear. It asks us to plug in some data points and solve from our equation. So this is really, really great. The only thing that I could ask that is not on here is asking you to write a relation that uses the independent variable. But we can talk about that a little bit when the question E comes up. So let's read the question and do these questions. Marcy speed walks at an average speed of 3 meters per second. She travels a distance d meters in t seconds. Create a table of values from this relation and identify the independent and dependent variables. All right, well, this one is not too bad, okay? Because when we have our table of values here, when it is at 0 seconds, when she hasn't started walking yet, she's gone a distance of 0 meters. When she travels 1 second, she travels 3 meters. When she travels 2 seconds, she travels 6. When she travels when she travels for 3 seconds, she goes 9 meters, and so on and so forth. 4, 12, 5, 15, 6, and 18. So we can just we've been prompted actually from even the way that our table is set up that I gave you, that time is our independent. So our indep is time in seconds, and our dependent is distance in meters. What we want to do now is use our table of values to graph. So I have created this table for you sometimes, or I've created this graph for you. Sometimes it's really difficult actually to determine the proper scale, and in the next video I'll just be doing a whole bunch more examples of this type of question. So if you don't quite get it after this video, don't worry. You can do some of the practice questions, but if you need a few extra examples, I'll have 4 more in the next video. So let's graph using our plotting skills that we learned in 6.1, or were reminded of in 6.1. Let's plot these. So the way that you plot them is you pretend that they're coordinate points. So when time is 0, distance is 0. When time is 1 second, so it goes up by 2 every 2, so this is 1 second, the distance is 3. So it's going to look more like here. 2 seconds, our distance is going to be 6. 3 seconds, our distance is going to be 9. 4 seconds, our distance is going to be 12. 5 seconds, our distance is going to be 15. Oh, not 8. 18. At 6 seconds, our distance is going to be 18. So this is part of the graph. Now the question here is, will you join the points on the graph? Explain. Now, the question to ask here is there something like 1.5 seconds? Yes, that is a quantity that exists. Is there such a thing as 1.5 meters? Yeah. So since there are partial answers, or like half meters or half seconds available, we can connect these dots together. Now, if we were talking about people, say number of people would be our dependent variable. You can't have 1.5 people. I mean, statistics tell us that, you know, like 2.2 people per household or something like that. But in actuality, you can't have a partial person. Or people don't sell pieces of pie in quantities other than one piece or two pieces. Let's go up to our question here. Is this relation linear? How do you know? Well, I can just even write in my Q's column here, and I can say D. Yes, it is linear because the data forms a line. The next question is write an equation that relates D to T. What I'm going to do is I'm actually going to write it up here because it's more helpful to see the data points when creating your equation than having to flip back and forth. So I am going to work on E. So we're going to go through the same steps. For every +1 in independent, we add 3 in our dependent. So I am going to just create my equation. D for our dependent equals something T plus something. Let's just remind ourselves here, D is because of our dependent. T is because of our independent. This will be our constant, which will come from our dependent variable when we plug in 0 into our equation. And the coefficient in front of the independent will come from how much the independent or how much the dependent variable goes up each time. I know that my my coefficient is going to be +3, and I know that my constant is going to be 0. So if I were to rewrite it so that, you know, the mathematicians with their creepy little fingers don't point and laugh at us, because we don't need to say +0. We just say D equals 3T, and that is it. Now the next two questions have us manipulating the equation that we have been given. So how far does Marcy walk in 15 seconds? So F, when time equals 15 seconds, what does D equal? Well, first things first, let's write out our equation. D equals 3T, but I know that T is 15. So I'm going to say D equals 3 times 15. So the distance is 45 meters. Done. We plugged in an independent variable and the dependent variable came out as 45. The next question. How long does it take Marcy to travel 1 kilometer? So this is a bit of a tricky one because we know that if we were to write this out, D equals 3T, we know that T is in seconds and distance is in meters. But we have been given 1 kilometer. So we need to convert that kilometer into meters. And there are 1,000 meters in 1 kilometer. So instead of putting in 1 for our meters, we're going to put in 1,000 because there are 1,000 meters in 1 kilometer. So I have 1,000 equal 3 times t. So what we want to do here is we want to isolate that time variable. We want to isolate the 3, and the way that we do that is we divide both sides by 3. When I divide 1,000 by 3, I get 333.3 repeating seconds. So to go 1,000 meters, or 1 kilometer, it will take 333.3 repeating seconds. So in summary, what did we do today? Today, we defined linear relations, and used tables of values, graphs, and equations to analyze word problems. For Math Excel, I'm going to give you 2. And don't be offended, okay? Grade 4. Ugh. H3. What I like about this one is it gives a context and it gives you a table to create an equation from. Now make sure that you do more than just like 1 or 2 questions from here, because they get tougher as you get closer to a score of 100 and you actually have to create an equation. For the first little bit you need to just like fill in one portion of the equation, but with the harder ones you actually have to write the entire equation yourself. So and then grade 7 V.9, this one gives you a graph and it gets you to complete a chart and create an equation for that one. So I like that one. But for this master check, I'm literally going to ask you to do any one of these questions here. Plus what I mentioned about another question I could ask is for you to create an expression. Okay, and the expression would literally just be this portion of the equation. Okay, just one side of it, not the dependent variable, but the part that has the independent, and I could ask you to express it in words. So as you go up 1 in the independent, you go up 3 in the dependent.